Hi, my name is Sandeep Mishra, and I'll be talking about a challenging part of C++, which is determining error and more specifically overflow error. Now, I believe that overflow error has been a part of, a problem in our homeworks, whether we understand it or not, whether we fully understand it, to grasp it, and it will continue to be part of other homeworks going forward. Um, so essentially, overflow error, the way we've understood it, could be easily understood. Instead of looking at the 32 bits, we can look at the 8 bits. Now, we've always understood it in base 10 logic, where a number should not be, for example, in an 8 bit, a number should not be um, outside of the boundary of negative 128 and 127. Okay, now that's good and all, but it's really important for us to understand overflow error in binary, in terms of binary, because that's where overflow really comes from. Whenever you use function int 32 max, int 32 min, which is what we've been doing, what we did for our homework before, is really important to understand overflow error in binary. So I do feel like the homework itself did an okay job in explaining it, but um, I think I can probably explain it a little bit better. So to start off, we can obviously people know what binary is. If we continue, it goes from sorry, 1 to 4, 8, 16, 32, 64, 128 onwards. Now, the 128 part, if you use int 8 max, the 128 part does not become 128. Um, Instead, the max number we have is this binary number we have is 127. And when we go afterwards, you would think that this is 128 itself. But no, this is negative 128. And the reason why, it's because of a concept that is beyond C++, but the concept is two's complement. So in two's complement, the leftmost number of the binary number determines whether it's positive or negative. So if it's 0, it's positive. If it's 1, it's negative. And the leftmost digit is the number itself, but it'll be the negative number of that version, so negative 128. To determine the negative number of the binary, you would pretty much locate whether it's positive or negative. This is just two's complement concept itself. So we have negative 128, and then locate the other numbers. So this position is 32, this position is 16, and if you go all the way here, this position is 1. And so we add all those positive numbers to that negative 128 to get this negative 79. That's why when we did our int product in the debugging lab, so if we look at 8 bits, 79 plus, let's just say, for example, 79 plus 79 is obviously over the value of 128. And the value itself is, if my math is correct, 158, which is obviously ahead of 127. Okay, but it's not even 158. From two's complement, it would be a negative. I believe it would be a negative if you do 158 minus 127, negative 31. Okay, now this is the reason why I went over two's complement is to further understand the concept of overflow error. And so if we use int32 max and 32 min, the numbers, the boundaries are way ahead, way too much to deal with than using simple arithmetic. So to understand that concept is very important going forward in our in our future homeworks, and it'll be a lot better to inherently understand this concept, so that there could be methods that deal with two's complement itself, because in C++, the the most challenging part is developing the method itself. And if you don't inherently understand some of the methods that go into certain errors, then it'll be very, very challenging. Thank you for listening to this short video.